Alright, back with section B of term 1, paper 1 for year 10. Let's have a go at these questions. Solve the inequality and show the solution on a number line. Get my little stylus back. I want to subtract 35 from each side, so I'm going to have negative 2t is greater than 12. Dividing by negative 2, when you divide an inequality by a negative, you need to change the direction of that sign. I've done that. 12 divided by negative 2 is negative 6. So now all I need to do is draw that on a number line. My number line is for t. There's my 0. Negative 6 is somewhere here. T is less than negative 6. And we're done. State the gradient and the y-intercept. Giveaway marks. Y-intercept 2. Gradient, coefficient of x, which is negative 3 over 7. Not just negative 3, negative 3 over 7. We should be right with that one though. Alright, let's keep going. Simplify the following. Just a few index laws here. Y squared, each of these terms gets cubed, so when I go negative 2, I'll write it out. Negative 2 cubed, x cubed. When I cube that becomes x to the power of 9. When I cube a negative number, it stays negative because it's going to alternate between negative, positive, so an odd power keeps it as negative. So it's going to be negative 2 cubed is 8, and then I've got x to the power of 9, y to the power of 2. And we're done. If you have them in a different order, that's okay. Next one here, 2 root 8 minus 4 root 3 plus root 12. Okay, so the root 8, I know I can simplify. That's 2 root 4 by root 2 minus 4 root 3. Root 12 can simplify. That's a root 4 by root 3. If you skip that line and just wrote this next line, perfectly okay. So root 4 is 2, so 2 times 2, that's going to be 4 root 2 minus 4 root 3 plus, and the square root of 4 is 2 root 3. Simplifying that, 4 root 2, take 2 root 3. And we're done. Okay, lucky last. Just a bit of simplification. Probably need to do a bit of factorising. Shouldn't be too challenging. I kept it fairly nice for you. So the 21r squared plus 14r is going to go on the top. But I'm going to factorise at the same time. 7r is a common factor there. And I've got 3r plus 2 left over, divided by 2. Now we can see things that can be factored and cancelled. Common factors are allowed to be cancelled. 3r plus 2 is a common factor. 2 goes into that twice, and it goes into this 2 once. Oh, good. My denominator's disappeared. It's only 1 now, so I don't need to write it. 2 times 7r, 14r. Sorry about that. Hopefully you could still follow that. All right, let's go over to question 4, over the page. The midpoint of the line is joining negative 2, 5, and 8, 2k plus 1. Is that? Determine the value of k. Well, we can just check the midpoint of the first one. Negative 2 plus 8, that's going to be 6 divided by 2 is 3. It's really only the y-coordinates that we're interested in. What's my rule? It's going to be the y-coordinate of the first one plus the y-coordinate of the second one, which is 2k plus 1, divided by 2, the average of those two. That's what a midpoint is. It's the average, so the average of those 2 points is equal to 16. Now we've just got an equation to solve. Okay, 2k plus 6, that's my numerator. 2k, 5 and 1 gives me the 6. I'm going to multiply by 2 to get 32. Subtracting 6, 2k equals 26. K equals 13. Alright, wow, complex familiar already. It doesn't take long if we know what we're doing. Find the equation of the line perpendicular to this line and passing through the point 7, negative 2. Well, if we want to find the gradient of this line, I think it's going to be easiest to rearrange it. So let's do that first. 3y is going to be equal to negative 4x plus 8. Y equals negative 4x plus 8 over 3. So the gradient of that line is negative 4 over 3. Therefore, the gradient of a perpendicular line is going to be the negative reciprocal, 3 over 4. So when I'm trying to find the equation of my line, it's going to be in the form y equals 3/4 of x plus c. We can substitute in the known point, which is 7, negative 2, to find c. So I'm going to do that right now. Negative 2 equals 3 over 4 times 7 plus c. Yes, I was a little bit cruel. I made you do some maths with fractions. Let's see if we can escape it okay. If you're a bit worried about the fractions, you can do it in stages. We could multiply everything by 4 and get rid of it. I'm not going to do that. I'm going to say, I know what I'm doing with my fractions. When I multiply a fraction by a whole number, it's just the numerator that gets multiplied. So that's 21 quarters plus c. I'm going to subtract 21 quarters from 2. So 2 I can think of as negative 8 quarters minus another 21 quarters. That's going to be my c. Negative 29 over 4 is c. So my equation is going to be y equals 3 quarters of x minus 29 over 4. If you wanted to write that as 3x minus 29 all over 4, absolutely correct and not a problem with that. Use an algebraic technique to solve the following equations. Okay, we've got simultaneous equations. It's annoying when they're written in different formats. Here I've got one with the x and y on one side, one with y on one side and x on the other. That's just someone being nasty to you. Just fix it up. Say, silly goose, Chewers didn't know what he was doing. Let me fix that up for him and we'll be okay. I'm going to keep this one here as equation 1. And right underneath, I'm going to put equation 2, but I'm going to rearrange it so that I've only got y as the subject. So negative 5y equals, and when I subtract 4x to get on the other side, I'm going to have a negative 4x minus 39. That's my second equation. Pretty good, except my coefficients aren't the same. What did I multiply? Equation 1 by 5. What's that going to give me? 10y equals 15x plus 120. And if I multiply the second equation by 2, it's going to give me negative 10y equals negative 8x minus 78. Okay, well, a little bit of multiplication there, but not too bad. What I have done is I've made the coefficients of y equal in magnitude. One's positive, one's negative. That's even better because now I can just add them together and they will disappear. So I'm going to add these two equations. I'm going to end up with 0 on that side. 15x minus 8x, well that's 7x. 120 plus negative 78, so take away 78. What have we got? 42. So 7x equals positive 42. This is going to be a piece of cake now. Negative 42 equals 7x. Negative 6 equals x. And you go, thought that was supposed to be complex familiar, Chewers. But you don't stop there, do you? A lot of people get tempted to. Some of you did in the exam. You don't stop there. You've only found x. You've got to find y. Let's let my stylus keep it on the page. Let x equal negative 6 in the first equation. Why not? So I'm going to have 2y equals 3 times negative 6 plus 24. 2y negative 18 plus 24 is 6. Y equals 3. Therefore, the solution is negative 6, 3. Or you could write it as x equals negative 6, y equals 3. And I said the words, but it didn't come out. There you go, it did that time. Not so bad. Alright, I might pause it there. I'll put the complex unfamiliar in another video. Again, I hope that helps. Catch you in the next one. Bye.